All right. Who's a good boy? Let's do this. G'day guys, Matt from Hal Heavy Duty. We are an Aussie machine shop that specialises in the drilling industry, and in today's video I just want to give you a little window into the kind of inserts that we tend to run in a shop that's sort of 50-50 between repair and also small batch production, usually of drilling crossover subs or rods, all kinds of stuff like that. So if you're brand new to machining, this is probably going to be a pretty interesting video for you, because this is what I would have loved to have known when I got started. Like, what inserts do I need to use for different things? If you're someone who's got a lot of experience, like you've been doing this for years and you watch this video, you're probably going to go, oh, he's missed out on X, Y, Z, or oh, I don't agree with that. Put it in the comments, because this channel is two things. One, a window into our world of what we do in an Aussie machine shop in the middle of nowhere, but also it's a chance for me to learn from people all across the world. And I do consider in the comments, especially when you let me know what your experience is, because that does help for me to, it's someone who actually knows what they're talking about. I do think about this stuff because I don't know everything. I'm not the most experienced machinist. I'm just a guy out here having a crack and making really big stuff as part of my job. So with that aside, when you see inserts, they always have four letters, or usually have four letters, right? So those just refer to the insert shape, the relief angle, the tolerance, and the chip breaker. So like WNMG. That's all it means, but I'll show you in the little book here. This is the Engineer's Black Book. We use it a lot in the shop. It's a really handy reference guide, but you can just see there's lots of different shapes, lots of different chip breakers, and they're all a little bit different. So when I'm saying inserts, you can refer back to this part and have a little look at, okay, what does that all mean? Now, the other thing I'm going to refer to in this is nose radius. All that means is that the corner of the insert has a radius on it, and it'll be, for me, all of them come in metric, so it's usually 0.4, 0.8, or 1.2. They're the typical nose radiuses that we run, those three on most inserts we carry, but that's all that means. So let's get into it. When it comes to external turning, like when I'm turning down a billet or when I'm roughing into something, for roughing, two inserts that we tend to use, or three actually. The first one is the W insert. So WNMG is probably more than half of the inserts that we go through is that insert. I find it to be super versatile. Like if I was starting a little machine shop or a hobby machine shop, that is an insert I would keep for sure. You get 6 corners. Now all that means is that each insert can be used, either rotated or flipped and used 6 times. So it's really good bang for your bucks. These have a maximum depth of cut, according to the manufacturer, of 4.5 mil. Now you can go deeper. We tend not to. I actually run the max cut at 4 mil. And for just roughing away and then coming in and doing a finishing pass where it doesn't have to have like a perfect mirror finish, these are such a versatile insert. They're very, very robust. They don't have a large angle on, like a relief angle on the back, but for general stuff and for machining 4140 steel, we use W inserts on our external tools in both CNCs and both little lathes, and on a lot of our boring bars up to 40 mil. So the W insert is just stock standard, a go-to. Now nose radiuses, both of these CNCs, they run a 0.8 nose radius for roughing, and if I've got to do like fine work on the inside, it's a 0.4. On the Hulk, it runs a 1.2. Why does that matter? With your nose radius, the larger the radius on the nose, the heavier cut you can take. And it's like, think of like an egg, that structure. The more curve you have, same with when you're designing lifting eyes. I know a lot of you criticized the hell out of me on that one for the nose radius, the radius in the corner not being so big because it affects strength. It was just a tooling factor. But you will find, like, if you want to not get vibration and chatter, like if I'm doing usually boring, I will use a 0.4 nose radius, because that also means that you can take a smaller cut with it still chipping and not vibrating. So for example, with a 0.08 nose radius, which is 0.8 of a mil, your depth of cut for it to chip should be 1 mil, right, over the nose radius. For a 0.04, half a mil and it'll still chip and finish up nicely. A 1.2, if you take a 1 mil finishing cut, it'll look terrible. So that's why we use the 0.8 WNMG in both of the CNCs, why the Hulk, because it's often taking deeper cuts. That's why we use it if we're going to run a WNMG, and the little lathes, they also run 0.8s. So that's one of my, it's a combination finishing roughing tool that we use internally and externally a lot. The most common insert in the shop. Okay, heavy roughing, the next one is a CNMG. These we use on the Hulk, on both CNCs from time to time, but on all of our heavy boring bars, so looking at both of the Kongs, the Beast, which is the biggest lathe in the CNC, and that thing is a 95 mil diameter bar longer than my arm that can take a 5 mil depth of cut. It runs a big CNMG insert, as does Tiny, the largest bar on the Hulk. Now, that kind of happened because in the cabinet we had a whole bunch of CNMG heads, so I just made boring bars out of them. If I could do it again, I wouldn't have purchased the head with such a large CNMG. These are running actually one of the biggest. We could have gone a size down and it would have been just fine. That's the other thing. Inserts also come in shapes and sizes. So you can, you can have the tiniest little CNMG insert, which we've got a lot of, but then you can have the really big, thick, chunky ones. One advantage of them though, is they are so strong. Like the swarf that comes off a broken CNMG insert, that's how you can usually tell, is you can hear it and you can see it, but these things will still cut when broken. So we've never had one other than when we were practicing on Tiny. We haven't had an insert actually break. They usually just chip off and the swarf looks like crap. You replace the insert and you're fine, which is good when you're doing like big, deep cuts and long runs, which we often do in the CNCs and in the Hulk. So that's why we use CNMG inserts on our boring bars. We also could use WNMGs on the larger ones, but I couldn't take a 5 mil depth of cut comfortably. So that's why we did that. On the smaller bars, right down from like 20 to 40 mil bars, so we've got 20, 32 and 40, they all run WNMG inserts largely, except for one in this CNC, which is a CXMG, I think. It's an ISCAR special. It's got a very positive chip breaker on it, and I use that when I have to bore very deep and I don't want to get any vibration or chatter. So that's the one bar that's a little bit different in that machine. This one doesn't have one. That's what we use for the heavy rough, or for what I call roughing. So you've got your W's, your C's, and the other one that we've just started using, which I'm a huge fan of, and shout out to Chris Marge, because that's where I saw a video of him just ripping into a monster depth of cut recently, you know, and went, yep, we need to get one of those for the machines. It's called a Fix 8 tool. So this is a Kennametal captive insert, and it is just the best tool for ripping off, like when you've got to remove a lot of material off a shaft, that is what we will use, is the Kennametal Fix 8 tool. It actually, the W, the C, all of those, they actually lay flat. This sits up vertically, and it's got a monstrous radius on it, so you can take huge cuts. You couldn't finish with it, but it's a really good tool. I wouldn't say it's any use for a home shop, but if you're ripping off a lot of steel and you haven't tried this one yet, it is bloody awesome. So yeah, your W's, your C's, your Fix 8 for heavy roughing. Now when it comes to finishing, we often use the WNMGs, just run the same tool and finish like that, but we also use a lot of your D-shaped inserts for finishing tools. So they're shaped like a diamond. They are brilliant. We usually use a 0.4 nose radius, and we've got them in a variety of sizes. Each lathe actually has these. Like if we're having to make really high tolerance stuff where you're down to like 0.01, for us that is high tolerance. Watchmakers are like, what? That's the size of my part. I love watching Click Spring because I'm like, man, that is just wild. The little teeny tolerances they carry, we don't have to worry about that so much. So if I've got to do, say, something that needs like a bearing where it's got to be press fit or it's got to be just spot on, we will usually use a D-shaped insert to do the finishing pass and bring it down to size. We also occasionally use V inserts, which are just like a skinnier diamond. They are really good, but they're a bit more of a fragile insert. So in our work environment, they get slammed like a screen door in a cyclone. Like they don't last very long, so I try to avoid using them in all honesty, but sometimes the application needs it. So other inserts that we have in our cabinet that we use a relatively large amount of are your square inserts. So we often just use these for chamfering. They're just set up as a little chamfering tool. Both of the manual lathes have them. I keep one on the big CNC for when I'm doing repair jobs. The little doesn't have it, and there's definitely one on the whole, because you can just go in and quickly do your chamfering. It works really well. They also, though, these S inserts can be used in a boring bar, they can be used in an external holder. The reason why we don't do that so much is because we use the C inserts, because I just find they work a little bit better, but that's just my experience. The round inserts that you'll see, like button looking inserts, we use those for when we've got a machine welds off. They're, like, consider it like a heavy parting tool. Like if you've got to go through weld, this is the best insert. Or if it's really bad conditions, like really interrupted cuts, nasty stuff, because the round insert is the strongest of all of them. So your R insert, and they come in a variety of diameters, they are super tough, like by far the strongest insert. And if you've got to do welds, or if I've got to pull something off where it's been welded on, that's the insert that I will use to get in there. I know that Curtis from Cutting Edge Engineering, he does larger hydraulic cylinders that we do in here. We do a lot of big stuff, but I don't see hydraulic cylinders in here over about 6 inches, just because you won't find them on a drill rig. So he's developed some tools on his channel that are just awesome, like super long button tools that can just get in there and take off welds and go very deep. We don't need anything like that here. We just use stock standard tool holders, but that's what we use when we've got nasty cutting conditions. I know inserts are probably going to break, or if I've got to go through welds, that's the insert of choice for this shop. And the last one of the standard sort of like ISO inserts that we use is the T insert. So it's a triangle shaped. We use that when we want to put different size chamfers on, but it can also be used, and we do in the little lathes, not so much in the big ones, but in the little lathes, we use smaller versions of these for internal boring. It can be used as a finishing tool. They're a very versatile, very inexpensive insert. They're also used for some of the inserts in the mill. They probably like the 4th most used insert in the shop. Like, we just use them for so many different things. We usually keep like a 0.08 nose radius on them. And they're also very good when we've got to do weld preps. So that's the insert that we use for it, a T-shaped insert. Most of the tool holders that we use for them, though, are where it's just sitting straight on, because that's the application that we use it for in here. So basic turning, they are the inserts that we use. Now the next thing that you're going to want to know is, well, what do we drill with? Up to a diameter of about 15 mil, we use high-speed steel. In the little lathes usually, or if we're drilling through flanges in our manual drill press, it's all just high-speed steel drill bits. We have a little sharpening machine for the little stuff, because my eyes are not as good as they once were, and I find it difficult to relieve the web on small drills, so we just have a really cool little machine now that does that. But on the larger stuff, we still actually sharpen them by hand. When we're doing stuff in the little manual lathes, we use high-speed drills. We have a whole set of them that go from about, well, right up to 2 inches, so 50.8 mil, and of every size in between, because sometimes we'll have to make something where that hole in the center could be any size. So we'll get the drill in, drill it out to rough it, and then we finish it with an internal bar. So we have that all set up. In the CNCs, I have set up indexable drills, or U drills. Both of them have varying sizes. The little one here has 32, 38, 42 and 50 mil, and it also has what's called a HTS drill for deep drilling. Now, my opinion on U drills, I've actually done a video for this on the channel, worth going and watching in my opinion, because it sort of goes through all of them. For the kind of work that we do, if I could set it all up again, I would get U drills that have 2 trigon tips. Some of them have like a trigon and then a square on the other side, or they have 2 square inserts. I hate those U drills. I just find that they squeal like mad. For me, The dual trigon tips, and our larger ones fortunately run that. The ones that we have are Kennametal, and they have a captive insert, meaning you can only buy it from Kennametal. If I could set it all up over again, not that I have a problem with Kennametal, I just find that using ISO, meaning it's an internationally standard insert, is preferable, because you can then, you're not beholden to one company, and you can actually buy U-drills from certain companies. There's a few of them out there where they run usually a WCMT, which is a standard insert. It's a positive single-sided insert that is the same trigon shape. It's just not specific to one company. So I would set all of these up with all trigon inserts and just WCMT, because they're very inexpensive, like a fraction of what a captive insert costs. So if you were setting something up and you wanted to get into U-drills, WCMT. That's my humble opinion. I drill in these all day long, and for 4140 steel, I've found that those two trigon tips way outperform the other ones, and they're just quiet as a mouse. So that's the U-drills that we have. Now, U-drills often will have on them, their size and diameter, and then 3D, 2D, 4D. All that means is how many times the diameter depth can you drill. So if it's a 4D 50 mil diameter U-drill, you would be able to drill 200 millimeters in. Most of what we keep here is 3D or 4D. The largest U-drill that we have, which is the 3-inch, it's only 2.5 because they don't make them any longer, unfortunately. So when we want to go deeper than that, what we do in the shop is we actually have HTS drills. Now, I chose Kennametal for this because we had a good relationship with the Kennametal dealer. They were comparable cost to Korea Technics. I just hadn't had any experience with Korea Technics. I checked out some reviews, and they're pretty much comparable. So I don't have I don't think one's better or worse than the other. I can just comment on the ones that I've used. These HTS drills are freaking awesome. We have a 49 mil one set up, and it'll drill up to 380 mil, and it just does it in no time flat. Before that, we used to use Spade drills. I'm not a huge fan of Spade drills. In the CNC, I don't like them. Granddad used to use a lot of Spade drills because that's the technology that was available. He has this wild tool that I've never ever run, but I'm just like, man, that is one hell of a way to get a larger diameter. He actually put two Spade drills together and used that. Just like the things you had to do, right? But in this lathe, there's a 49 mil HTS drill, and then this one is a 63 mil, the larger one of the two. And we also have a shop-made one we called the Kraken that ran in here for a while until I killed it because its nose was too long, and I should have shortened it, but I didn't. I was a mixture of hope and stupidity on that one. The HTS drills, they do squeal a little bit, but the metal removal is just so fast. I highly, for us, it's been a real game changer in here for when I have to drill deep stuff and I want to get it to a pretty accurate, size with really good finish on the depth. Those HTS drills are great. And the inserts, one thing I will say, which I didn't expect, they really hold up. As long as you don't peck drill with them, which we had to do with the Kraken, just because I didn't have enough Z-axis load in the big lathe. These HTS drills, that's the little one, the 49 mil one, it still hasn't had to have an insert changed yet, and I have drilled hundreds of holes with this now. So yeah, they're very good value. A bit of money to set up, but once you've got it set up, and if you're doing deep drilling, you will, you will just be like, why didn't I do this sooner? So they are the drilling options that we use for in here. I know there's a lot of new drilling technology coming out that we are going to be looking at, but for the moment, that's what we use. Now the last thing is threading. What do we use in the shop for threading? Both CNCs and the little lathes are fitted with top-notch tool holders. That is a system from Kennametal for threading. Is it the best? Probably not. In fact, for most of the people who are very experienced in machining, there's better stuff out there now. The reason why we use it is because it's very versatile. We already have about $3,000 worth of tool holders, which I don't want to lay out the money to replace. But for the applications that we use, I can very easily purchase these inserts and for all different types of threads. So having just a few different size tool holders means I can cut just about everything. We are exploring other options there. I'll just say this right now. So if you've got a really good threading system that you love, that you think is better than the Kennametal Top Notch, oh man, drop that in the comments for me. As I said, this video, I hope to get as much out of it as you do. And I hope some of this has been interesting to you. It's a bit more of a technical, detailed video than I would normally do. Usually I just like to rip into steel, but I've wanted to do this for a while. So they are the inserts that we use in the shop. When it comes to grooving as well, we use for like your smaller grooves and square threads, again, Kennametal Top Notch. They have an entire range of grooving inserts, threading inserts, so that's what we use there. So there you go. That is what we use in an everyday machine shop that's about 50-50 small batch production and repair. That is, for me, my goal with inserts has always been to keep it as condensed as possible while still not losing necessary tools, which I think we've more or less done in here. I think I probably halved the number of inserts that we use since I took over this shop, just because you don't necessarily need as much as you think. Like, you can get away with having just a good range of ISO inserts and a few specialty tools, and you can make just about anything. So anyway, guys, if you're new to the channel and you enjoyed this, don't forget to subscribe. To everyone who's a part of the channel, guys, you have no idea how much I appreciate you. I love reading the comments each week, and I'm looking forward to seeing what the comments on this video are. If you got something out of it, let me know what you learned. And if you've got something to share, make sure you pop that in the comments, because I absolutely will read it. I do my best to respond to every single comment because I really enjoy chatting to you all. Well, anyway, guys, that's it from me. I will catch you in the comments, and I'll catch you on the next one. It's a chippy. Chippy?
Chippies.
Chippies. Thanks, buddy. Chippies? Big chippies. Big chippies.
Yeah.
We go? Beep, beep.
Beep, beep.
Beep, beep. Let's go, boys.